All right, here we go. Again, note card. Last things to add for the note card. These are half angle identities. Half angle identities. Your first one is the sine of x over 2 is positive or negative the square root of 1 minus the cosine of x all over 2. The cosine of x over 2 equals plus or minus the square root of 1 plus the cosine of x all over 2. And tangent has 3 of them. Tangent can be the sine over the cosine, which is 1 minus cosine of x over 1 plus cosine of x. Or, I forgot the plus or minus in front. Or they can be ones without radicals, which I prefer. The tangent of x over 2 equals sine of x over 1 plus cosine of x, or tangent of x over 2 equals 1 minus the cosine of x over the sine of x. Now, if this was an advanced trig class, we'd figure out how each of these identities. Okay? But since this is just the basic trig class, we'll just go with it, and you'll trust me that these work. All right. Now, half angles are important. Half angle identities are important. The double angles, I don't really worry too much about those. The half angle ones, yeah, it's important you understand these. Like the cosine of 15. The cosine of 15 is the same, is the cosine of 15 on your unit circle? No. And we've done them by using addition or subtraction methods, but here's a half angle method to do the same thing. The cosine of 15 is the same as the cosine of 30 over 2, which is 30 is our x. Okay? 30 over 2 is 15. Okay, so you just double this, and that's what you get on top. So, if that is that, then we take, what quadrant is the cosine of 15 in? Quadrant 1. So, is the cosine going to be positive or negative in quadrant 1? Positive. Okay? The square root of. And then we go 1 plus the cosine of 30 degrees over 2. Because we use that number, not the 15. Okay? Well, what's the cosine of 30 degrees? Square root of 3 over 2. So we end up right there. But we have a complex fraction, right? Because a fraction within a fraction. How do we get rid of a complex fraction? Multiplied by the denominator of the denominator. Well, in this case, we're going to just multiply by the denominator of the numerator. We're going to multiply everything by 2 on the top and bottom. So we're going to get the square root of 2 plus the square root of 3, because 2 times 1 is 2. 2 times 3 halves, the 2's canceled to get square root of 3, over 4. And then we'll just take the square root of the top, which is 2 plus the square root of 3, and the square root of the bottom, which is 2. And there we are. You got a square root inside of a square root, and you're stuck with that. That's just the way it is for these. That'll happen on these. Okay? All right, let's do a tangent one. Let's do the tangent of 3 pi over 8. Ooh, what's 3 pi over 8? Well, that's the same as the tangent of 3 pi over 4 over 2. Okay? You just take this one, make it twice as big, and divide it by 2. Okay? Because the tangent of 3 pi over 4 is on your unit circle. Okay, so which one should you use, you ask? I always like to use the last one when it comes to tangents. The last one is 1 minus the cosine of x, which is 3 pi over 4, over the sine of x, which is 3 pi over 4. What's cosine of 3 pi over 4? Negative square root of 2 over 2. What's the sine of 3 pi over 4? Square root of 2 over 2. Minus a negative is? Plus positive. Do we have a complex fraction there? Yeah. So how do we get rid of the complex fraction? We're going to multiply them by 2. Can't cancel because there's addition there. So we're going to distribute, and we get 2 plus the square root of 2 all over the square root of 2. Can you leave square root on the bottom? No. So we multiply top and bottom by square root of 2. And you get 2 square root of 2 plus 2 all over 2. Oh, what can we do now? Factor out of 2 and cancel. So it's the square root of 2 plus 1. Okay, square root of 2 plus 1. Let's do one more. Let's do the sine of let's do another cosine one. It'll be fine. I just don't have a good number for that sine one. Let's do the cosine of 11 pi over 12. The cosine of 11 pi over 12. That's the same as the cosine of 11 pi over 6 all over 2. Okay? So it's equal to the square root of 1 plus the cosine of 11 pi over 6 over 2. Now, where is 11 pi over 12? What quadrant? Nope. Try again. 11 pi over 2. Not 1. 2. Quadrant 2. What's cosine in the second quadrant? Negative. So your answer is going to have a negative out in front. That's why on your note card it's plus or minus. Okay? But in this case, it's going to be negative. All right. What's the cosine of 11 pi over 6? Square root of 3 over 2. So then, at this point, you multiply by 2 over 2, because you got a complex fraction. So you get 2 plus the square root of 3 over 4. That's negative. So then you end up with negative the square root of 2 plus the square root of 3 all over 2. Any questions on that? Okay. First section you had 6 questions. This section you have 6 questions. We're going to do 9 through 14, all of them, on page 193. Last regular assignment of the year. Then on Friday in here, we'll go over these 2 assignments, and you'll have a review worksheet. And then on Monday, we'll take the Chapter 3 test. Then Wednesday and Friday will be work days for your semester project, and your semester project's due Friday. And then Monday after that is review for the semester test.